Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so we're continuing on with our logs works, and these are some of the questions that I got asked to do that people found a bit difficult. Okay, so this is the first one. If log to the base 6 of x plus log to the base 6 of y is equal to 1, show that x is equal to 6 over y. That's part A, and then hence solve the simultaneous equation. There's that log line, and then 5x plus y is equal to 17. Okay, so let's consider the top part first. So if we look at this, you can see that in the show that they have somehow eliminated or cancelled out all the log parts. Okay, so how did they do that? Well, let me take it down here. So log to the base 6 of x plus log to the base 6 of y is equal to 1. Okay, so I like to use these ones here because I play with the fact that logs and indices are the opposite of each other. Okay, so let me bring them onto this page and let's have a look at how this could be used. Okay, so I see these are logs. So if I raise it to the same base number that's with the log, what will happen is log A and A will cancel and I'll be just left what's up here in the power. Okay, I like the look of that here because I can see all the log pieces are all cancelled. Okay, so either of these works. You can either have a power and then get the log of it, or you can have a log like we have and raise it to the power. Okay, so what's the key? You match the base number. So that base number there is A. If I go back to the log tables, it might be easier to see before I copied it. Well, not really. So you match the base number. Okay, so what does that look like here? Well, my base number is 6 all the way across. Okay, so that means that I will raise everything as such. Okay, plus. Now, I have to add, I'm doing this incorrectly first, okay, because I want to show you a common mistake, okay, or something that's really easy to do. You know you need to use one of these rules because it cancels them, and so you dig into that rule straight away, okay, but I want to show you what happens, okay. So log to the base 6 and 6 cancels, log to the base 6 and 6 cancels. Okay, now notice what I had to do to the right hand side of that equals to sign. I also had to raise that to the base 6. Okay, what you do to one part you must do across the whole equation. Okay, but what I'm getting here is x, so all that's left is the power. Okay, just like the rule told me, all that was going to be left was this. So x plus y is equal to 6 to the 1 to the power of 1 is 6. Okay, or if I write it in terms of x, that means x equals, I'm going to get x is equal to 6 minus y. Okay, and that's obviously not what we got. Okay, so what did I do wrong? It's nearly right, but it's not right. Okay, well, we have it almost right. So using this rule is correct. That instinct is correct, but to use that rule, let me take down the sum again. To use that rule, I must have just one log to the base 6 on the left. Okay, so I must resolve this. In other words, I must add these logs. Okay, so let's go back to our log tables. Let's see, is there anything here that would help? Well, this is a log to the base A plus a log to the base A. So in other words, the base numbers are the same. And when the base numbers are the same, I multiply them together. Okay, that's what that rule tells me. So let's employ that rule. Let's write this as log to the base 6 of xy is now equal to 1. Okay, so to explain that again, I have log to the base 6 of x here, and I've log to the base 6 of y here, and that's going to give me log to the base 6 of xy. Okay, now I can use this rule here. Okay, so let's raise everything up to that base number. Okay, so that log 6 and 6 cancel, and I'm left with, on the left, just xy being equal to 6 to the power of 1, which is 6. Okay, now you're looking up here to see what do I need to do to it to make it look like what I was asked. Well, you're just going to divide across by y, so that they cancel on that side, and you're now writing it in terms of x. So x is equal to 6 over y. Okay, so I hope that's clear. So you'll see when I do a lot of log questions, I use these rules a lot because I like the fact indices and logs are the opposite of each other and they cancel each other out. Okay, so let's do the simultaneous equation. So it told me that the first one was log to the base 6 of x plus log to the base 6 of y was equal to 1. And my other equation was 5x plus y is equal to 17. Okay, so if you got that without having this part at the start, this part at the start, then the first thing you need to do is get rid of these logs so that you can, I suppose, solve it like you would any other simultaneous equation. Okay, so we have already this done. X is equal to 6 over y. We had that from part A. Okay, so I suppose all I can really do is sub that in here for x. You've solved it for x, so, sub it in. So that he becomes 5 times 6 over y plus y is equal to 17. 5 sixes are 30 over y plus y is equal to 17. Okay, so the easiest thing here now to do is to get rid of that. We don't particularly want fractions. So how about we multiply across by y? So multiply by y. Okay, so multiply this bit by y, this bit by y, and this bit by y. Okay, so what will happen is the y and the y there will cancel and you'll just be left with 30. You'll have y by y to be y squared equals 17y. So let's write that as our quadratic, and remember our quadratic is ax squared plus bx plus c is equal to 0. Okay, so let's write our y squared first. Let's bring over our 17y and it's going to become minus 17y, and then plus 30 is equal to 0. Okay, the factors of plus 30, that gives me 17, 15 by 2, 15 by 2, because minus by minus is always a plus. So the negative version there will give it to me. So y and y minus 15 and minus 2 is equal to 0. Y is equal to 15. Y is equal to 2. Okay, so I hope that's okay. X is equal to 6 over y is equal to 15, and y is equal to 2. Okay, so I see this one is in terms of y, so let's tidy that up a bit. So y is equal to 15, y is equal to 2. So let's work out our x's. X is 6 over y, so in this case it's 6 over 15, and in this case x is equal to 6 over 2, which is 3. Okay, and you can write him as, you can divide top and bottom by 3 if you wish, whatever way you want. Okay, but there's your x's and your y's, and there's your simultaneous equations solved for x and y. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.